Hello everybody and welcome to another session of the July daily challenges. Today is day number 3, so we are on day number 3 today. So welcome everybody, and I hope you're enjoying these July daily sessions. For those of you who don't know, we are running a few daily sessions, that is every day at 10:30 a.m. we launch a new challenge. Today's challenge number 3 called European Iteration. When is the challenge launched? Every day the challenge is launched at 10:30 a.m. and the first to crack the challenge is on top of the leaderboard. You too can sign up for this challenge on the link over here. So that's this link, bit.ly/Edyst-JulyDC. It's also mentioned in the description below. The toppers for today, day 3, are these 5 people. So congratulations to these 5. That is Satish Adabala, Satish Naidu, Satya Tulsi, Harshvardhan and Nikita. So congratulations to you. You are day number 3 toppers, and very good. You solved it really quickly and you are on the top of the leaderboard today for day number 5. Day number 3. You are the top 5. So yeah, huge congratulations for you, and all the best to everybody else for the upcoming challenges as well. So today we are going to cover challenge number 3, but before I get to that, if anybody is facing doubts or questions regarding the challenges, so these July daily challenges are completely free, but if you are facing doubts, if you don't know certain concepts and you want to learn those concepts, you can go over to the Edyst CodeVita course that is on this link over here. Also the description for that is in the link for that is in the description below. Early bird offer has been extended because CodeVita themselves postponed to August. So we have extended the early bird offer. Please go up and sign up for that. There are mentors to solve your doubts. So if you're facing doubts on certain concepts, you can just go to that, go to the mentors and ask your doubts. There are tutorials. All of the concepts are covered, right? And for more details, you can just go through our previous CodeVita videos and you'll understand what I'm talking about. Okay, so let's get to today's challenge, and today's challenge was called European Iteration. It's a play on the Roman iteration question which is asked in CodeVita 2019. So this is also previously asked CodeVita 2019 question. Let me open it up on the Edyst platform by going to that same link, Edyst, so bit.ly/Edyst-JulyDC. This is the link that opens up. So if I go, I'll see this link. When I click this start coding now, it will ask for your email ID and password. And once you do that, you are put into this page over here, right? And so this is challenge number 3, which is what I'm opening right now. And the feedback I got was actually this challenge is was better than the previous 2 challenges. I don't know why, but if it was, it's great. You're a good coder because this is actually question number 2 or question number 3 from CodeVita. So if you were able to solve this easier than the question 1, it's a little bit of, I think the logic for the question 1 was too easy that you weren't able to get it so quickly. So yeah, let me get started with this one. And before I start, also please don't forget to subscribe to this channel if you're finding it useful, and share not only this channel but also the daily challenges with your friends, so they also can form a habit of coding and every day start coding for CodeVita. Okay, so let's look at this question over here. Number 1, this question is very much similar like CodeVita, so like very much in line with what all CodeVita asks. So generally any CodeVita question will have a bunch of steps that you're supposed to do. This is one of those. Like for example, many of you will remember the prime Fibonacci question. It's in the playlist below, but you can go and check. That also had multiple steps. Here also we have multiple steps. So the first step is you're supposed to accept a natural number n as input. If n lies in the closed interval 1, 2, 3, 999, which what that basically means is between both 1 and 3, 999 inclusive, right? So this closed bracket means this, open bracket means you don't have 1 and 3, 999 in the interval, but here it's closed means we are using it. And what we are saying is we should check this and convert it to a Roman numeral, and then once it's converted to a Roman numeral, we have to consider now that Roman numeral not as a Roman numeral but as a number in the place value system, and again calculated in base 10, and then convert that to a Roman numeral, check if it's in 1 to 3, 999, and so on, and that this keeps continuing again and again. Now for those of you who are like, what just happened, I don't know what's happening here, I'll just explain it in more detail right now, and we'll just look at an example and also do. But before that, let's cover a few key concepts so that we know how to solve such questions, right? So we'll cover a few key concepts and then we'll understand. So these are the steps that we're supposed to follow. That is, we're supposed to take an input n in base 10, and if n is in so and so thing, then we'll convert it to, you know, some Roman number. Let's say it's called Roman numeral, right? Roman underscore n. And you know, we don't really need to, I'll get into a detail of how this Roman numeral comes, but what you have to do is find the Roman n in the minimum possible base. Again, this minimum possible base, what does it mean? We'll look at it, right? And then we'll take that, we'll make n is equal to that value, right? And rather value or Roman n in min base, right? Let me just write it like this. I'll explain what this means. Don't need to worry about that. Hold on 1 second. Yeah. Okay. So, and then we have to keep repeating these steps. We'll look at an example and then we'll understand. But as I said, again, we'll first understand these two concepts. What is a Roman numeral? I think many of you know. What does min possible base mean here? And then what does that mean to convert it back into a decimal? We'll look into that. Let's look at the first concept. So the first concept is, what does a number in another base mean? So before that, let's first understand what decimal base is. For many of you, this will seem like a very basic concept, but I see many college students are not very familiar with the whole decimal system, binary system and all. So let me just explain that. The general numbers that we use, okay, let's say you're talking about your currency, you're talking about you know, your marks in a subject, whatever you use, everyday daily life, when you count from 0 to 9 and then 10 to 19 and so on, every time when you use that, that is called the decimal system. And why is it called the decimal system? Because it only has 10 digits. So how many digits does it have? It has, including 0, it has 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 digits totally, right? So, or rather 0 is the first digit all the way up to this. So you have 10 digits. What this means is basically once we are done with 9, once we are done with 9 over here, we will start again from 1. So that is, in the next position we place a 1, and this becomes 1 0, 1 1 and so on, right? It just keeps going like that. That means that now this units place will again recycle through the same digits, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then in 10th digit we will come up with the new digit, right? So which is like 2 0, then 2 1 and then so on, right? So now we are going to recycle that. So basically a binary system is just when are we ticking over, right? In a decimal system, sorry, not binary system, what I meant to say is a number system is when we are just ticking over. For example, in a decimal system we tick over when we reach 9, and then the next significant digit is the one that's incremented and the current digit goes back to 0. So you reach 9 and then the next one becomes 10, so it becomes 1 0. So on you go to 19, then it becomes 2 0. Then again you go to 29, it becomes 3 0 and so on, right? So that's what we keep going forward with it. So there is no special, like we use base 10 in real life because we are, like, as humans we are very accustomed to it, but there's no special difference between a base 10 and any other base as such. Like for example, you could use, let's say you use a binary system, base 2, right? So all this means is that there are 2 digits, right? 0 and 1, that's it. Or if you use base 3, then you have 3 digits, right? 0, 1, 2. And base 13 I'll get to, but you have these 3 digits. And these digits are actually just symbols, right? So you could have actually base 1000, base 10,000. All you're saying is you're going to count up until that many digits in the units place. And the moment we are finished with those digits in the units place, we'll say let's tick over, that is we'll go to the next level by increasing the next significant digit by just 1 digit, and this current digit keeps increasing. So for example, in base 2 you have 0 1, right? So you have let's say you have the number 1101 over here, right? What does this mean? Well, before that, the way this is base 2 is binary, the way it will work is the first number will be 0 0, or rather just 0, then the next one will be 1, then the next one, we already reached 1, the highest digit possible, right? So now the most significant bit has to tick over, so it becomes 1 0, then 1 1, then again we reached 1 already here, so the next significant bit has to tick over, right? So it becomes 1 0 0, right? Because this ticked over, it became 0, this also ticked over, it became 0, now this becomes 1 0 0, then 1 0 1 and so on, right? It keeps on increasing like that, right? How do we convert this back into a decimal value, that is in a value that is understandable to us? Well, similarly as to how this would be expressed, right? For example, if I were to express 30 or any other, like so for example, if I'm expressing 30, how do I express 30? 30 for me is 3 into 10 raised to 1 plus 3 into 10 is plus 0 into 10 raised to 0, right? That's how it is. That is, with every position we associate an exponent of 10 or whichever base we are in. So here in binary, what we are doing is, with this position we associate 2 raised to 0, 2 raised to 1, 2 raised to 2 and 2 raised to 3. That's why we get 1 into 2 raised to 3, 1 into 2 raised to 2 plus 0 into 2 raised to 1, because this is 0, plus 1 into 2 raised to 0. Fairly standard stuff if you've done bases and systems before. If not, I'll suggest you go and read up further into this, as it is an interesting concept and CodeVita seems to like it. Last year there were about 2 questions on it, and generally it is a question, like binary systems are questions, our favorite questions of competitive interviews and programs, right? So this would amount to 13, because 1 into 8 plus 1 into 4, 12, plus 0 plus 1 into 1, which is 12 plus 1, 13. Let's look at base 13, okay? Nothing to do with this 13 actually, I just wrote it like that, or we can just make it base 14 as well. For base 14 means we will need to have 14 digits, right? So if we have base 14 and 14 digits, we'll have 0, 1, 2, 3. So till now we got how many? 4 digits. Now we got 5 digits. Now we got 6 digits, 7 digits, 8 digits, 9 digits, 10 digits, 11 digits, 12 digits. We need one more digit, 13 digits, right? So C would be 13 over here, right? C would be the 14th number rather. So you start from 0. And if you had to, show 14 in this, what you do, you'd get from 0 all the way up till here, right, which is C, you'll get 13. And if you had to show 14 in this, how would you show it? So let's actually put that as well over here. So in base 14, what we want to do is that we want to compute a few numbers. So what we're going to do is, we'll check, let's say we want to compute 14 itself, right? So how would you describe 14? You would describe 14 as 14 into, 1 into 14 raised to 1 plus 0 into 14 raised to 0, right? Which is equal to 1 into 14 raised to 1. There will be 1 over here and it is going to be 0. So like in base 14, 14 itself is 10. How did that happen? A lot of you might be wondering, why didn't we just do 14 into 14 raised to 0 and then just remove this part completely? Well, the reason why we didn't do that is we have only 14 digits here. That is, the maximum digit we have is 13, that is C, right? We don't have a 14th digit as such, which goes to show you that if you have these many number of digits starting from 0, that means that the maximum the digit that you can get is base minus 1. So you got, for base 14, the maximum digit you could get is base minus 1. The moment you want to get to the actual base, you have to tick over to the next one, right? Let's look at another example here. Let's look at probably something like 27, right? So if I want to look at 27, how would I describe 27? 1 into 14 raised to 1 plus 13 into 14 raised to 0, right? Which is equal to 1C. That's what it's equal to, right? So you got 14 plus 13, which is 27. Right? So that's how these numbers work. Now, if I give you a number like AB10C, right? What is the minimum base I need to represent AB10C? So what is the minimum base that is needed to represent this? Well, I could have this in like a huge base. Can I have digits up until 100? Yes. So you can, or even like 36, 46, whatever, right? The reason for that is you can have those digits and C will definitely be part of that. But what is the minimum we need? Well, if our base was 13, then we would not have C as a digit, which means that this would not be able to be represented. Only because we have a base 14, we can at least get C over here as a number, right? So that's what the question actually asks for. What is the minimum base for each of these numbers? So for example, let's look at this. For 74, we need a minimum base 8 because we need at least 7 digits, right? There is no, like, could it have been 749? Yes, but it's not, right? It's 74, which means that the minimum, or sorry, the maximum digit that we have seen so far is 74, is 7. That is, the minimum base I require is 8 to get this value. Similarly, for 39, the minimum base I require is 10 so that I can get the 9 digit. For 3, the minimum base I require is 4. For like we were saying A, B, C something, the minimum base I require is 14, right? So I require base 14 over here. Now 74, let's say it's 74 in decimal. In base 8, 74 means completely something else, right? So if 74 is decimal, sorry, 74 is base 8. What does it mean in decimal? It means 7 into 8 raised to 1 plus 4 into 8 raised to 0. That's what it means. So then what you get is 7 into 8 raised to 1 is 56 plus 4, which is equal to 60. Right? We can just double confirm this. 7 into 8 is 56 plus 4, 60. Right? So this is the value in decimal over here. Right? This is the value that you will get in decimal. Right? So that's the decimal value that you have. Okay. Now this is what we will need in our specific question. So let's just go back to the question again. What we are saying is, if n is in this, n is firstly in decimal base, so we are happy with that. Now if n is in this, then convert it to Roman. We'll just come to that Roman numeral in just a bit. But assuming I have a Roman numeral, which if you all remember is just some alphabets, right? It's not really any numbers. So if I will get that, and I want to say, to represent that Roman numeral, what is the minimum base I require? And I will get that minimum base. I will try to find this value, like 74, the minimum base I require is 8, which means that the actual decimal value of that is 60. Similarly, I'll try to find the minimum value of this one, of this Roman numeral in its minimum base, right? And that value has to then be checked further, right? So you have to check that further. You have to check whether that is again in 1, 2, 3, 999. If it's not, then just print it. If it is, then again convert to Roman numeral, and so on. That process keeps continuing, right? Okay. So for this, what we need to know is the Roman numeral part, right? So let's look at the Roman numeral part and just come back here. So those of you who you might have already heard about Roman numerals, so let's look at Roman numerals as well. Roman numerals has these symbols. So 1, V, X, L, C, D, M, right? These are the symbols. I corresponds to 1, V corresponds to 5, X corresponds to 10, L to 50, C to 100, D to 500, M to 1000, and so on, right? This is the corresponding values. And if you wanted to just press 10, you do X, and it's like one of those where you don't have too many digits, so you just keep repeating the digits. So like for example, you want to mention 13, you would be X, I, 14 and 39 are exceptions. I'll come to those in a bit. But let's say you had 27, right? So the way you would express 27 is 20, 5, 1, 1, right? So that's how 27 would be represented. Now, Roman numerals isn't just about adding the value. Sometimes you have to subtract as well. So for example, for 14, you will say 10 or XIV, which is basically you have 15 or you have 10 plus minus 1 plus 5. Right, so it's minus 1 plus 5. That's how it is. So it's X minus 1 plus 5, which is 10 minus 1 plus 5, or 10 plus 5 minus 1, that way. Similarly, 39, you will have X, that's 30 minus 1 plus 5. So that would become 39. That's how you would represent it. Okay. Similarly, 400, you would not represent it as C. You would represent it as CD, that is 100 minus 500, or minus 100 plus 500. Because if a lesser number comes before a bigger number, then we do a minus of it. Okay, right? So we have this, and now you might be thinking, what are these arbitrary rules? Like, when do we put a minus? So for example, why don't we make 8? Why don't we make 8 as IIX rather than you might have never seen this, right? Rather, this is wrong. Rather, we always use it as VIII, right? We never do IIX. Well, there is a certain convention to it. Generally, now the Romans themselves were not like fully, they didn't have, or probably they had standards, I'm not sure, like, properly documented standards, but there are multiple ones, but the most popular ones follow this kind of a standard. Okay. What you do is for 4, for 9, for 40, for 90, for 400, for 900 are the ones that you make certain exceptions for. For example, 4, you will make minus 1 plus 5, 9 you will make minus 1 plus 10, 40 you will make minus X plus L, XC you will make, 100 you will make it as minus X plus C, right? So that's how you will make it work. And so this is something that, I mean, you don't need to by heart this or memorize this as such. This is a fairly standard thing, and especially generally most questions will ask you till 3999 only, and so that is what you need to know. You don't need to know the values for 5000 and so on, or 10,000 and so on after that, right? So how does this work, right? What you have to do is similar to what we discussed. Treat this as digits, right? And treat these as your significant values rather than treating as digits. For example, you have to break down 2943 into multiples of 1000, 900, 500, 400, 100 and so on, right? So what you'll get is, 1000 is 2 into 1000 plus 900 is 1 into 900 plus you don't get any 500 values because you got 2900, there's no 500 left. So this way, you, let's say if it was 2500, you would not have got any 900 values, you would have gone directly to 500, right? So there has to be a 900 value, there has to be a 40 value, and there has to be a 3 value. Okay, so treat each digit separately and see what you're getting. So for example, the first thing is 2000, right? So how did we get that? Because we first divided by 1000, right? And we got 2, right? So we know that integer division. So we know that the coefficient for 1000 is 2. The coefficient for 900 is 1. When you divide by 500, we got the coefficient as nothing. When we divide by 100, again we got the coefficient as nothing. When we divided by 90, again we got nothing, because what you are left with is 43. With 50 also you got nothing. With 40 you got 1 as the coefficient, and then now you're left with 3. So then only with 1 will you get a coefficient of 3, which means that you need 2 of the 1000 digits. 1000 digits is m, so you'll get mm. You need 1 of the 900 digit, which is cm. You need 1 of the 40 digit, which is, where is 40? 40 is here, which is xl, which we got here, and you need 3 of the 1 digits, which is this I. So I. That's how we calculated this 2943. Okay, so I hope you understood Roman numerals as well. I mean, all of us have used it. We write our class standards, etc. also in it. But this is the, like, if you want to calculate it by computer, this is how you do it. Treat each of these as a digit and check how many is the coefficient, and accordingly take that many. Right? Okay. Now let's come back to the question and let's look at the steps that we wanted to cover. So these are the steps. So let's look at it step one by one. If n is in this, convert it to a Roman numeral. Let's take an example. 1 in Roman numerals is I, right? So I'll convert it to I. Now that I have to find the value of Roman numeral in the minimum possible base. We converted it to I cannot exist in certain bases. For example, I does not exist in decimal. I does not exist in base 11. I does not exist in base 12. Which is the minimum base in which I exists? The minimum base in which I exists is 19. That is, I is the 18th digit over here, right? Or actually I is the 19th digit, but its value is 18. So you'll get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So till here we got 10 digits. Then we got the 11th digit here, 12th digit here, 13th, 14th, 15th, 16th, 17th, 18th and 19th digit. If there are 19 digit, means the base is 19 and the value of this is 18 because we started from 0. So the value of I is 18. So in decimal, I would be 18. Okay, which means I have to convert it to a Roman, and as we just discussed, a Roman value of 18 would be x v I, right? Again repeating, I is what I got. I took this 1 as an input. I converted it into a Roman value. Why did I convert to a Roman value? Because 1 lies between 1 to 3 999. So I converted to a Roman value. And after converting it to a Roman value, what did I get? I checked what's the minimum base required for this. So the minimum base required is 19, which means that my value of I is 18. Now if it's 18, I will try to 18 again repeat this entire process, right? So I got this 18. This 18, is it between 1 and 3 999? Yes, it is. So as we did over here, get the minimum possible value, n is equal to that value. So we got n as 18. Is 18 in 1 to 3 999? Is it? Yes, it is. If it is, convert it to a Roman. If I convert 18 to a Roman, I get x v triple I. So I got this x v triple I over here. After we got this x v triple I, what should we do? We convert it to a Roman, right? Then we should again convert this, find the min base for this. What would be the min base for this one? See, up until 36 you will get z, right? So you would need a base of how much? So because the 30, so let me just check. So what is the minimum base that you will need? Probably 35, right? 35 is the minimum base, because to accommodate z, if you have to accommodate z also, then you would get how many digits? You up until z there are 36, so that means the base would be 37. Up until y is 30. Up until y is 35 digits, so you would need base 36, and up until x is 34 digits, so you would need base 35, right? So up until x is base See, basically 0 to 9 gives us 10 digits, right? Plus A to Z gives us how many digits? Another 26 digits, right? But therefore up until x I will get 24 digits, right? That means there are 34 digits completely. If there are 34 digits including x, that means the base is 35. In base 35, what is the value of x, v, I? Well, you have to get their corresponding value and multiply. For example, whatever value of x is, as we just saw, it's 34, right? So is x 34? Yeah, x is 34. 34 into 35 raised to 2, 3, 4, 5. 35 raised to 4, and you convert it basically in the bases, right? So how it would be is whatever the value of x into 35 raised to 0, 1, 2, 3, 35 raised to 4 plus whatever the value of v into 35 raised to 3 and so on, right? And that's how we'll keep going on with it. Value of I into 35 square, value of I into 35 raised to 1, and value of I into 35 raised to 0. We go on, we get this value. So we'll finally get this 4533890. We again go to the second step, because we'll again repeat second step. Is that big value in 1 and 3999? No, it is not. Therefore, we just print the n value, right? So this is what is required to us. So essentially you require only 3 functions over here. So if I can just write down, you need a function to convert it to a Roman numeral. You need to find the minimum base, which is fairly simple to do. That is, find the value of the maximum digit in the number, and then try to find out the value in decimal. Get the decimal value of any of this value, right, in that particular base, and that is your new value, which you will again check in step number 2 if it is in 1 and 3999, right? So between that you will check and you will keep going forward. This is better explained by code, so let me just show you the code for this one, which is also, you can also unlock this code. Let me just show that to you. You can unlock this code here in the hint section. You'll give up some points, but you can still unlock. So I'm just going to go ahead and unlock it. So basically this is the one that will convert to a Roman numeral. What we're doing is we made the symbols over here, and for each of the symbols what we're doing is we'll check the coefficient. So I'm checking the quotient, how many ever the quotients were there. So for example, for 2000 I need 2 such 1000 numbers, right? That means I am going to, in my answer, going to add 2 m's, so it becomes mm plus whatever I need to add further on, right? So that's how we're calculating the Roman numbers. So I'll also show you another one, which is the get the maximum digit, so that we can find it. So for the maximum digit, what we do is we actually just compare all of the digits in the number, right? So basically I took input first over here, right? This is the number n, and what we are ensuring is that the number n is in this 13999, right? And if it is in this 1 to 3999, otherwise we just print n. So if it is there in this, then what we'll do is we'll get the maximum digit in it. The maximum digit is the the base is the 1 plus the maximum digit that we got. So for that I used this get value function to find the value of this digit. Fairly simple. So for example, if we had x over here, how would we find the base for it? Well, I just go to this get value function. Just by using the ASCII values, I am getting what should be the actual value of x. It's fairly standard. I think you all can solve that. That x would be what? X would be 34, right? So how do we get 34? That's what this function is doing. Once I got that, what I want to do is I want to get this newly converted Roman number, that is this Roman number, in that base. I want to find that value, and if I got that value, that is, I store it in n, right? Because that is my new n. Once I got that value, I again go back and check whether it's between 1 to 3999, and I'll continue this process again and again. So getting this in base decimal value is, again, what we do is we multiply that particular value by the base, the exponent of the base, right? That's what's happening over here. We'll try to multiply it like 10 raised to 1 into 10, or so we start from the most significant, 10 raised to 3, then 10 raised to 2, then 10 raised to 1, and so on, right? So that's how we are making this value. But pretty much self-explanatory, the code. You guys can go ahead and check out the code as well. And just to show all of you as well that it does work. Okay, I already have the code here. So if it does, just submit it, and yep, it does work. So a fairly implementation based question, which is called the Roman iteration. I hope you all understood what this question is about. Each step is a different step, and you have to solve each step separately. Not too difficult, not too easy. Simply if you went in the systematic approach, then you would have got the solution to this question. So yeah, everybody, that's this question. Make sure that you go ahead and try it out if you haven't yet tried it out. Just a reminder to everyone that there is a question called prime phase, which is available in the CodeVita course, and if you want to sign up for the CodeVita course, then you can just go to this link and sign up for it. Prime phase question is very similar to this one, and there are such similar questions which you really need to prepare for. So go ahead and try it out. Tomorrow we will be back with challenge number 4. So let's see who solves tomorrow, who's going to be on top of the leaderboard tomorrow. If you have any doubts or if you want to go ahead and try out this question, you can go on this link. If you have any inquiries about our upcoming courses or any course, you can go to this number over here for WhatsApp or just email us. Just again a reminder that we have a brilliant course that has come up, which is everything to do with projects. How do you make an amazing project that you can show on your resume, and if you show such projects on your resume, you're definitely going to get hired. If you're able to answer those questions, if you're able to just show that you've worked on such technologies, and that is the Webmaster Bootcamp, and you can find that on the Edyst website as well. I'll just show that to you also. One second, let me just show that one. So if you go to courses on Edyst, one second, and you can also find that over there. So if you click courses on top, this is the Webmaster Bootcamp. It covers both front-end and back-end web development, led by my co-founder Abhinandan, and it's really amazing. You can just go ahead and check all of the projects that you do. It's some of the really amazing stuff. Go ahead and at least try the free module. You have one free module over here, and then you can sign up for this course too. So yeah, those of you who want to make the most of the lockdown and learn new skills, that's another option for everybody. Thanks everybody for joining in today. It's getting fun with these daily challenges. Hit the like button if you liked this video, share with your friends, subscribe to this channel, and comment below what you liked, what you didn't like, what are the kind of questions you want us to cover going forward. We are more than happy to listen to you. Thanks everybody, and I'll see you all next time. Thank you.